So we want to graph a logarithm. Now, when we graph a logarithm, we go to the back cover of our textbook, and we go to the bottom. There's two different logarithm graphs. This one is when your base is a fraction. This one is when your base is a whole number, bigger than 1. Sorry, this one's a fraction, this one's bigger than 1. So if your base is bigger than 1, you use this one. If it's between 0 and 1, which is a fractional base, you'll use this one. Now, we're going to look at question 2, which has a base of 5. So we're going to be using this graph here. So we're going to be graphing f of x equals log base 5 of x minus 1. And just so we have a rough idea of what the graph should look like, it's going to vaguely resemble that. Want it? Okay. Now, remember our translations. What is this negative 1 here going to do? Well, that negative 1 is inside the operation. When it's inside the operation, that's the opposite of what you think it should do. So instead of it moving it back to the left, it's going to move it forward to the right, 1 unit. So then we're going to have to add 1 to all the x's. And just so we know, what's our base? Our base, in this case, is 5, right? That is your A there. So that's your base of 5. Now, normally what we need are these points. We need A, comma 1. We need 1, comma 0. And we need 1 over A, comma minus 1. But what are we going to have to do to all of our x values? We're going to have to add 1 on, right? So we're going to have to add 1 to all of these. So what does this one look like? Okay, A again is 5. So this one's going to be 5 plus 1, comma 1. This one we add 1 to it, so it's 1 plus 1, comma 0. We're adding 1. What about this one? The last one here. Well, it's 1 over A, so that is 1/5. We're going to add 1 to that, and we're not moving it up or down any, so it stays the same. This is going to slide this graph forward 1 unit. So that means we have to adjust all of our points by 1 on the x components. So we have to add 1 on each one of these, and let's see what we get. Well, 5 plus 1 is 6, so we've got 6, comma 1. 1 and 1 makes it 2, comma 0. Adding those together, we get 1 1/5, comma minus 1. We know our graph should look like this, but what's going to happen to it? It's going to be slid forward 1 unit. So it just slides forward. We adjusted our points. So we've got 6, 1. So that's right about there at 6, comma 1. So that's what we've got there. What about the next one? Okay, the next one is at 2, 0. So that's back here. Make sure the points look correct. And then we've got 1 1/5. So that's right about there. Negative 1. Now we know that we slid the graph forward, and normally it would have a vertical here at x equals 0, but ours is going to have a vertical slid 1 unit forward at x equals 1. We know what it looks like. We curve them together, and there's your picture. So that's what your graph should look like. Now, what's the key part that we need to make sure we're aware of? we have a vertical line here at 1. Why is it at 1? Because this negative 1 inside, what did that do? That slid it forward 1 unit. So normally it's at 0, so it slides it forward, and that made me adjust all my x values by 1. And I just wanted to work through one of these as kind of a review. And question 6 is just converting it to, so we can see here. Question 6 is convert this to a logarithm. So we're going to write this as a logarithm, and we've got 2 to the negative second power equals 1/4. Now, what is our formula? Well, our formula is this. X equals AY converts into Y equals log base A of X. And you go back and forth. So when I convert this, what does this convert into? Let's label our components. So this 1/4, that is your X. This 2 here, that is your A. And this negative 2, well, that is your Y. So when we rewrite this, what do we now have? Well, we now have, when I rewrite it, minus 2 equals log base A, which in this case A is 2, of 1/4. And that's all you need to do. Just rewrite it simply as a logarithm. All right. Well, if we don't have any other questions, do we have some? Huh? Sure. Question 5? Yep, we can look at question 5. Question 5 is the log base 10 of 100. Okay, we want to find that. So we want to find out what log base 10 of 100 is. Now, we can convert this, which I'll convert it. I'll also show you how to use your calculator key. So let's say that's going to equal x. So we don't know what it is, but we need to find that value of x. Well, what do we know? We change a base formula. We know x equals a to the y power, converts into y equals log base a of x, right? Okay, so let's convert this into an exponential. Right now it's a logarithm, so we're going to convert this into an exponential. So this is going to be your y. This right here is going to be our x, and that is your a. So when I convert it, what does that look like? Well, when we convert it, we have 100 equals log base a, which is 10. 10 goes here, that's your base. Y is what? Y is x. Now, what do we know? We know that we need to find that x. And how do we approach that? Well, we need to make sure that the bases are the same. And we know that 10 squared is what? 100, right? So I can rewrite this as 10 squared equals 10 to the x power. So x has to equal what? 2. Now, there is a much easier way to do this. I'm going to show you how to use your calculator. This was log base 10. If it's log base 10, you can use the log key in your calculator. But this only works for log base 10. This is the one that most of you have. Most of you have this style of calculator. Now, this only works when it's log base 10. So as long as that's a 10, you can use the log key in your calculator. So we'll get the same answer if we type log of 100. What does that give you? The same answer of 2. Now, that only works when that's a 10 there. If it would have been a 4 or a 3 or anything else, we cannot use our calculator. But if it's a log base 10, or there's no base, it's assumed to be a 10, then you can use the log key in your calculator here. You get the same result. Or you can just rewrite it like I did, use that exponential to logarithm conversion, and we know that 10 squared is 100. Rewrite it and get the answer. Either way, it's the exact same way. If it's log base 10, you can use your calculator. Any others to look at? I'm going to take care of most of those. Okay. Well, we're going to start our last homework packet. So just so everyone knows, we'll be meeting on Thursday. We're going to go over some more out of Chapter 5 today and on Thursday. Just a minute. Okay, I'll get you one in just a minute. So we're going to go over today. We're going to be working on Chapter 5. This is our last homework packet. What we're going to be doing next week is we're going to be going over and preparing for the final. Now, I am going to give you a take-home final and an in-class one. That way you get ready for your final and you'll do very well. We're going to spend the entire that week before finals working and getting ready for our final exam. You're going to get a practice one. You're going to get a take-home one. You're going to know exactly what's on there. Students usually do very, very well on that final exam. So this will be our last homework packet before the final. So you got the right one here, should be chapter 5. Just make sure you have the right one. If I gave you the wrong one, let me know. Oh, sorry about that. Sorry about that. There you are. Okay, and this should be, for the most part, a pretty easy chapter. We're only covering 3 sections of it, and you probably have seen this before in your other math courses. We're going to be looking today at Chapter 5, which is solving systems of equations. So today, we're going to be looking at 5.1 and 5.2. And we're going to be learning different techniques for solving equations. And this is what's called a system of equations. Now, when I talk about a system of equations, that means several variables and equations. So we're going to be looking at systems that have several variables and several equations. So we're going to learn first how to solve this with substitution. So this will be the first method we're going to use. We're going to learn substitution today and elimination. Next class period, we'll learn Cramer's rule. So this is an example of a system. We're going to solve this one with substitution. So I've got to make up something that'll work here. Come up with the answers. I'll just make these up as we go through. We could pick problems out of the textbook, but I'll just work these out real quick here. Okay, so that one's going to be 3 plus 6 makes it 9. So that's going to equal 9 there. 4, and that should be 11 there. Okay, let me just double check, make sure I did it right mentally here. Yep, that looks right. 15 minus 4. Yep. Okay. So this is our system of equations. And the first method we're going to learn how to use is what's called substitution. Now, we substitute one variable into the other. So we take an equation and we pick a variable and we solve for it. We have to use both equations. We've got two equations and you've got to use them both. So the first thing I'm going to do is I'm going to see which equation and which variable is the easiest to solve for. Well, the first equation looks like it's very easy to solve for the variable x, right? You want to try to avoid fractions if possible. Sometimes they're inevitable, but you really want to try to avoid any fractions if you can. So if I solve for x, I won't get any fractions. If you solve for y or x here, you would. So let's take that first equation and let's solve it for x. So how would I solve that for x? So you're going to take that first equation and you're going to solve it for x. Well, to solve it for x, you're just going to move that 3y over with subtraction. And now we've got x equals minus 3y plus 9, right? Okay, did I give everyone hopefully the right homework packet? Okay. Now, what do we do from here? We used our first equation. So I like to put a check mark when we use it. So I used our first equation. Now we take our x that we found and we plug it into the second equation. So let's take this and plug it into the second equation. So everywhere we see the x, we're going to replace it with this. So we've got a 5, and then we're going to replace that x with a minus 3y plus 9 minus 2y equals 11. And we'll distribute that 5 through, and that's going to be a minus 15y plus 45 minus 2y equals 11. Now, we are down to one variable. That's what we want. We want to get this down to one variable so we can solve it. Then we solve it by plugging it back in to get the other one. You have to get the values of both variables. You have to use both equations. So we use the first one here, and we're using the second one here. So let's clean this up. Putting those together, we get minus 17y plus 45 equals that 11. We're going to move that 45 over. This is nothing but algebra. So minus 17y equals, we've got 45. We're going to take away that 11, and that gives you that minus 34. We'll divide by our 17, our negative 17 here. And that leaves you now with y equals negative. Negative makes it a positive 2. That's only half of it. We need to find the value of the x and the y. Now, once you have one of the variables, you just plug it in and get the other one. It doesn't matter where we plug it into. So we have half of it. So I'm going to take this 2, and I can plug it in wherever I would like, but I'm going to plug it, I think, back into here, into the second equation. So let's plug in that 2. So we have 5x minus 2, y was 2, equals 11. So that is 5x minus 4 equals 11. We're going to add our 4. And so now we've got 5x equals 15. So x now equals 3. What's our answer as an ordered pair? Well, our answer as an ordered pairs, remember, go x, y. So our answer as an ordered pair would be 3, 2. And that's it. That's called substitution. I'm going to pick some questions out of our textbook that also have substitution. So instead of making up some more of these, I think I'll just pick some from our textbook here. Okay. How about we look at question number 10, and this is on page 536. We're going to look at question 10. And we've got 6x minus y equals 5. Y equals 11x. Now, in some cases, substitution is the easier way to do these. In other cases, we're going to learn about elimination next, which it's usually easier. This one is substantially easier than the last one, because when we use substitution, which is what we're doing here, we're going to use substitution. If I can spell right today, let me write it right here so it looks right. We're going to be using substitution on these. So, what do we know about the second equation? When we use substitution, we look and solve it for a variable. Well, if we look at that second equation has already been solved for the variable y, hasn't it? So all we then really have to do is use that equation and plug it into the first one. So in some cases, substitution is the easier way. The last one was a little bit more difficult with substitution, but it could be done. This one's easy because it's been solved for y. So I'm going to plug it in. So that gives you now 6x minus y is at 11x, and that equals 5. And 6 minus 11, well, 6 minus 11, that makes it a minus 5x equals 5. Divide by our negative 5, and now we know that x is what? Negative 1. How do we find the other variable? Once you have one of them, how do you get the other one? Plug it back in. Does it matter where I plug it back into? No. Whichever one's easiest. So let's plug it in here. If I plug it back in over here, then I get y equals 11 times negative 1. So y equals negative 11. Make sure you write your answer as an ordered pair. And as an ordered pair, that would be negative 1, negative 11. Right, that's it. Let's do one more using substitution, and then we'll talk about elimination. And then we'll look at special cases from there. So let's look at one more using substitution. It doesn't matter which one I pick. Let's look at question 15. Again, page 536. We're going to look at question 15. And that's minus 2x equals 6y plus 18, and a minus 29 equals 5y minus 3x. So this is what we've got. Now, how do we go about using substitution? Well, we look for which variable is the easiest to solve. We have to use both equations. Now, look at this equation right here on our first equation. It's going to be really easy to solve for the variable x, isn't it? Why can I do that? Well, if I divide by 2, does that make any fractions? No, because 6 over 2 is 3, 18 over 2 is 9. So let's take our first equation, and let's go ahead and solve for x. You can use either variable. It doesn't matter. So divide by your negative 2, and then reduce it all down. So x equals now a minus 3y, and 18 over negative 2, well, that's going to be a negative 9, right? What do we do with this? We now take it and plug it back in. Where do we plug it back into? It has to go into equation 3. Plug that in. So what do we now have? Not equation 2, sorry about that. So that goes into equation 2. So what do we have if we plug in that x? Well, we've got a minus 29 equals that 5y minus 3 times a minus 3y minus 9. And now we know what to do, because now we're down to one variable. So we can distribute that negative 3 through. And we've got minus 29 equals now 5y. Negative and negative makes it a positive 9y. Negative and negative makes it a positive 27. We'll finish it by adding those together. So we'll go ahead and combine those x's together. Sorry, not the x together, the y's together. And 5 and 9, that makes it 14y plus 27. Is that minus 29? We're going to move that 27 over. And I'm going to rewrite this now. Those are the same. 29 and 27. Let's go together to give you now 14y, when I move it over, equals a minus 56. Divide by our 14, and it should come out evenly. And what does it now come out to give you? 4. How do we find the other variable? The one that we're missing? We plug it back in somewhere. Does it matter where we plug it into? No. You can even plug it back into here if you want it. Doesn't matter. I'm just going to plug it in there. As long as you plug it back in somewhere, that's all you have to do. So now when I plug it back in, okay, I've got x equals minus 3 times y, which is 4, minus 9. And we now have a, well, I missed a sign. There should be a minus portion. Yeah, sorry about that. Watch your signs. Be very careful. It's very easy to make a mistake. It should be a minus 4 there. And now we've got a negative and negative. That makes it 12 minus 9. And 12 minus 9 leaves you with 3. And so what does the answer look like? As an ordered pair? Well, as an ordered pair, X always goes first, Y is second. So we found X to be 3 and Y to be a -4. Okay, that's solving using substitution. I think we'll go ahead and do a couple more with substitution. These are going to be a little bit different, and then we'll do elimination. So I'm going to do the special cases first. And let's look at question 33. Well, we'll do 31 first because it has no solution. Most of the time, you're going to get an ordered pair for the answer. But there are cases where you won't have an answer. And it will either have no solution or it will have an infinite number of solutions. So let's look at this one and let's see what happens. Now, whichever way we solve it, we're going to get fractions. So not going to be a big deal. We'll work with those fractions. And I'm going to have you use substitution again. You could solve this also with elimination. But let's just do this with substitution. So I'm going to go ahead now and solve this for either variable. How about we solve it for y? So let's take our first equation and solve it for y. And we've got 9x minus 5y equals 1. So move that 9x over. Now you will make fractions, but that's okay, because we'll work with them. So moving that over, solving it for y. We'll divide by our -5. And that gives you y equals now, negative and negative makes it positive 9/5 x. Positive over negative makes it -1/5. Now, something different is going to happen when I plug it in here. When I plug it back in to that second equation, because you use the first equation, now we have to use the second equation. You have to make sure you use them both. What's going to happen when I do that? Well, when I do that, I get -18x plus 10 times 9/5 x minus 1/5 equals 1. Distribute that 10 through. What do we do with this 10? Remember, we divide and multiply. So 10 divided by 5. 10 divided by 5 is 2. 2 times 9 makes it what? 18. So we've got a -18x, we've got a positive 18x, and we've got 10 divided by 5, that's 2. 2 times a -1, that makes it a -2. What's different about this one versus the others? Well, what's going to happen to the 18x's then? One is positive, one is what? Negative. So these go together and they're gone. So what are we now left with? We are left with -2 equals 1. And can this happen? Can -2 equal 1? No, that cannot happen, right? Those are not going to be equal. So this has no solution. And since it has no solution, here's what we call it. Okay, it has no solution. So we use the 0 with the slash with the empty set, and it's called inconsistent. So it's an inconsistent system. Now, why is it inconsistent? It's inconsistent because it doesn't work. It's a contradiction. And what's basically happening is this. You've got two lines here. Okay, so these ink pens are going to represent the lines. If I look at these ink pens here, move them up so you can see. Most of the time, they're going to be like this. And they're going to cross at one point. So somewhere, in most cases, they're going to cross at one point. But what about this one? This one has no solution, so it looks like this. And these ink pens never cross, do they? Right? They're parallel. So that's why it has no solution and it's inconsistent. So the three outcomes that you can have is this. You can have the ink pens cross like this. You get a point. Most of the time, you're going to get a point. That's what we have done on the previous questions. Is they had an answer right here. You can have something like this, where they never cross. Or what we're going to look at next is one where they're actually on top of each other like this. So those are the three cases. So that one had no solution. That is like a contradiction. And remember, when we talked about equations, we talked about the contradiction, and we also talked about the identity. Right? The contradiction had no solution, and the identity had an infinite number of solutions. So next we're going to look at one that has an infinite number of solutions. So we're going to look here at question 34. Okay, question 34. And this again is on page 537. And we've got 3x plus y equals negative 2. And 9x plus 3y equals negative 6. And I always like to label the equations when we use substitution. Bless you. If I was looking at this and I want to use my first equation, which variable would you solve for? Would it be easier to solve for the x or the y? Which one? Y. Because y is going to be the easiest. No fractions. So let's do that. Always go the easiest route you can. So we have 3x plus y equals negative 2. I'm going to move that 3x over. Now we have y equals minus 3x minus 2. And what do? We used our first equation. So take that and plug it in our second equation. It's called substitution because you substitute one variable in for the other. Now, what's going to happen when I do that? We have 9x, then we have a 3. Y gets substituted with a 3x minus 2. And that equals your negative 6. But this one's going to be different from the last one. Because when I distribute through, you get 9x minus 9x minus 6 equals a negative 6. The 9x's can cancel, and you get this. Well, this is true. So this has an infinite number of solutions. And when it has an infinite number of solutions, what you do is you solve it for y. And that's going to be part of your answer. So this is true. It has an infinite number of solutions. And here's how we write our answer. So we're going to write our answer as this, the infinite number of solutions. Now, x is the arbitrary x. And then we solved for y. So it has to be in the same variable. We solved it for y, which we did here. So our x is our x. And then y, which is over here, what was y? Y was minus 3x minus 2. And that's your answer. What is that? That is when you have two lines that are exactly the same. So that's like having this line and another one on top of it. Where do they cross? They cross everywhere that's on this line, which is this equation. So again, what's our three different scenarios? One solution, no solution, infinite number of solutions. Let's do one more that has an infinite number of solutions. And then we will look at solving using elimination. And if we have time, I might do a 3 variable. If we don't, it's not that important. I didn't give you any in your homework. 3 variables work exactly the same as 2 variables. They just take longer to work through. And if we have time, we'll do one. If we don't, that's okay as well. So let's do one more of these. Let's look at 38. And question 38 is 2x minus 8y equals 4. And your other equation is x minus 4y equals 2. So, two equations, first and second. Always go the easiest route. Try to avoid making fractions when you use substitution. Try to go with the easiest variable and the easiest equation. If I look at this top equation, I'm going to have to divide. The second equation, though, I can solve for x very easily just by moving that 4y over. So that's what we're going to use. We're going to use that second equation. And we're going to take that second equation and we're going to solve for the x. So we've got x minus 4y equals 2. So we'll add our 4y over. And now we've got x equals 4y plus 2. And I put a check mark by 2 because we used it. So whenever I use an equation, just to keep track of things, I put a check mark by. Which one have we not used? The first one. So what do we do with this? Plug it in. So plugging that in, that's going to be 2 times 4y plus 2 minus 8y equals 4. Distribute your 2's through. And that makes it 8y plus 4 minus 8y equals 4. The 8y's can cancel, and you get 4 equals what? 4. And that's true. Now, how do we write our answer? It's a little bit different from the last one. Well, how we write our answer is like this. We know it has an infinite number of solutions. How we always write it is the first one is always your x. And then what you have to do is take one of the equations and solve it for y. So this one's always x when it's an infinite number. And this is right here is going to be solved for the variable y. So arbitrary x. Solve one of the equations for y. It doesn't matter which one. We have to solve one of them for y. So let's just take this equation up here. X minus 4y equals 2. And we're going to solve it for y. Move our x over. So minus 4y equals a minus x plus 2. Divide by your negative 4. Now we can rewrite this as y equals negative and negative makes it a positive 1/4 x. 2 over negative 4 reduces down to a negative 1/2. And that's going in there because that's your y. So that is then 1/4 x minus 1/2. And that's your answer. Okay, an infinite number of solutions. And what you always do, if it's an infinite number of solutions, is you take that one of those equations and solve it for y, and that goes here. X always is x, y is whatever y is. Solve in terms of x. Now let's talk about elimination. So we're going to be solving using elimination now. I really don't care which way you solve these equations. Thank you. Most of the time you're going to probably use elimination. It's just easier to do. So we're going to solve these with elimination. We'll do one or two of them that don't have fractions. And then we'll look at a couple of them that have fractions. So we're going to solve this using elimination. A different way of solving these. Let's look at question 21. Actually, let's start with an easier one. Let's do 20. 20 is a little bit easier than 21. So for question 20, we've got 3x minus y equals minus 4. And we've got x plus 3y equals 12. Now, we could solve this with substitution, but it's going to be easier to solve it with elimination. Now, we need to pick a variable, and we need to eliminate it, so it needs to go away. And how we do that is by multiplying and adding down. Now let's take our equation and let's try to eliminate x. So I want to eliminate x. So how would I eliminate x? Well, I can take my second equation and I can multiply it by negative 3. Why would I do that? Well, when I multiply that second equation by a negative 3, the first equation just gets copied. When I multiply this by a negative 3, look what happens here. That becomes a minus 3x, negative 3, and 3 makes it a, negative 9y there. Make sure I get the signs right. Negative 3 times positive 12. That's a negative 36, right? Why did I do that? What happens now with the x's? When I add down, what happens to my x's? They go away, don't they? This is called elimination. You want to eliminate one of the variables using multiplication. So this one had a 3x, this one just had an x, and I realized if I take the second equation and I multiply it by negative 3, then they're going to cancel. So one positive, one negative. Now, let's add down. The 3's, they can cancel. 3x's can cancel. And that adding down gives you a minus 10y. Adding down, that's a minus 40. And now we can solve it. divide by your negative 10. And so we now have y equals 4. Are we done yet? No, because we have to get the other one. Now you could eliminate again, but I don't mind if you use back substitution, because I think that's the easiest way to do these, is eliminate for a variable and then back substitute. So take this 4 and plug it into one of the equations. It doesn't matter where. Let's just plug it in here. So plug in your 4, and that is then 3x minus y, which is 4, equals that minus 4. Now we can solve this, so add your 4. So those go away. So 3x equals 0. Divide by your 3, and x now equals 0. So as an ordered pair, what would my answer look like? Well, my answer is going to look like 0, 4. Let's do another one with elimination. Let's look at, how about question 22? And again, we're going to solve with elimination. I don't really care how you solve them. I just wanted to show you both substitution and elimination. Most of the time, though, you're probably going to use elimination. It's just easier. Elimination with back substitution. Now we've got 4x plus 3y equals negative 1. And we've got a 2x plus 5y equals 3. I need to eliminate one of the variables. Now, what I do is I look at my numbers all together. So I look at the x's and I look at the y's. When I look at the x's, we've got a 4 and a 2. The y's, we have a 3 and a 5. So I'm going to eliminate for the x. Why? Because 4 and 2 are smaller than 3 and 5. And how do I figure out what number to use? Well, look at it as a least common denominator. The least common denominator of 4 and 2 is what? 4, right? It's the least one that will go into both. So what are we going to do? We're going to eliminate for this variable x. And I need to make sure that I get a negative 4 here. So this one's a positive 4. I want this one to be negative so it cancels out. Now this is a 2, so let's take our second equation and let's multiply it by a negative 2. And then we're going to rewrite it, and we're going to see what we have. So we're going to eliminate for x. It doesn't matter which variable you eliminate. You usually just want to choose whichever one's easiest. So now we've got 4x plus 3y equals negative 1. That stays the same. Distributing through here, we have a minus 4x. Negative 2 times positive 5, that's a minus 10y. Negative 2 times positive 3, that's a minus 6. If we did it correctly, we should eliminate the variable x. And that works because those go away. And so what are we now left with? We're left with a minus 7y over here. Minus 1 minus 6 makes it minus 7. Divide by your negative 7. And now we have y equaling 1. How do we finish it? We take what we found here, plug it back in. Does it matter where it goes? No. I'm just going to plug it in the first equation. Plugging that in, you get 4x plus 3 times 1 equals a minus 1. So that's 4x plus 3 equals minus 1. Move that 3 over. So 4x equals a negative 4. So x equals negative 1. What's my answer as an ordered pair? Well, as an ordered pair, that answer would simply be negative 1, comma 1. So there's your x and there's your y. How do we handle fractions? Well, if you have fractions, you clear them out. So let's look at question 28. We're going to do a couple of these. So let's look at question 28 here. So we've got 3x over 2 plus y over 2 equals a negative 2. And then we have x over 2 plus y over 2 equals 0. You could get by without clearing out the fractions, but I think it's going to be easier if we do. What do I need to multiply this by on both of these to clear out my fractions? Well, what do we have below? We have a 2 below, right? So I need to multiply everything by a 2. That's going to clear out all of my fractions. So let's do that. Multiply each equation by a 2. So every part gets a 2. When I do that, then I'm left with those cancel. 3x, those cancel. Positive y. Watch the right-hand side. 2 times negative 2. That makes it a negative 4. Next equation, those cancel. So that leaves you with an x. Those cancel. So that leaves you with a y. And 2 times 0 is still 0. Now we've got something that we can very, very easily work with. I could eliminate for the x, but it's going to be easier if I eliminate for y. Because look at these. These are both y's. Now, they are positive. I want one of them to be negative. So let's take our second equation, and let's distribute through a negative. That's going to switch my signs out. That way we can eliminate for the y. So we now have the first equation, 3x plus y equals a negative 4. I'm going to distribute through down here, and that makes it a minus x, a minus y, and 0 times a negative is still 0. Now, when I did that, what happens to the y's? Well, the y's go away, don't they? So 3x minus x, that leaves you with a 2x. Minus 4 and 0, that leaves you with a minus 4. We'll divide by our 2. So x equals now what? Negative 2. How do we find the other part? Well, when you plug it back in, do not plug it into something that has a fraction. You would plug it in over here. Do not plug it in here. Why plug in a number in a fraction? So just plug it into something that doesn't have a fraction. So let's plug it in here. You could have plugged it into this one as well. Doesn't matter. But let's plug that negative 2 in. So that's going to be, when I plug that in, and I'll write it over here, 3 times a negative 2 plus y equals negative 4. So that's minus 6 plus y equals minus 4. I'm going to add my 6 over. And so y now equals 2. As an ordered pair, what is it? Minus 2, 2. Question 30 is another one with fractions, but we're going to have to be really careful when we clear them out. A lot of times, students make mistakes with these, with something like question 30. And I gave you one of these, I believe, in your homework. I gave you a couple fraction ones, but okay, this is going to look like your homework here. Actually, I took that complicated one out, but there are some that have fractions. So several of these that have fractions. So there's some here, and there's some of them up here. But let's look now at question 30. Students sometimes struggle with how to clear these fractions out. For question 30, we've got x plus 6 over 5 plus 2y minus x over 10 equals 1, right? Our second equation is x plus 2 over 4 plus 3y plus 2 over 5 equals a negative 3. This one's going to be a little bit more intense when we clear out the fractions. So I'm going to do each one separate. So let's start with equation 1. Right? So equation 1, we've got this. Now I'm going to split this up, just so we don't make mistakes, into individual parts. So I'm going to split this up into x over 5 plus 6 over 5, that's there, plus 2y over 10 minus x over 10 equals 1. So I split everything up into the individual parts. I want to clear out my fractions, so I'm going to multiply it all by 10 because my largest denominator is a 10. Very good exercise in clearing out fractions. And how do we clear our fractions? Divide and multiply. And this is equation number 1 here. So our first equation, number 1. 10 divided by 5 is 2, so that makes it 2x. 10 divided by 5 is 2, times 6 makes it 12. 10 divided by 10, that leaves you with a 2y. 10 divided by 10, that leaves you with a minus x, and that equals 1. Clean it up. So we're going to put the x first. So 2x and a minus x, that leaves you with a positive x, right? Those go together. We have a 2y, and I'm going to move the 12 over. So that leaves you with that. It is a little bit of work to do that, but we just cleaned it all up, moved things around, and we got to this point. Now this is our first equation. Now, let's repeat the process with the second equation. And then we'll put them back together and we'll solve it. This is the hard part, actually. So what we've done here, this is going to be the harder part. Move this out so we can do the second equation. Okay, let's try to do the second equation the same way. Second equation. I'm going to split it up. We've got an x over 4 plus 2 over 4 plus 3y over 5 plus 2 over 5, and that equals a minus 3. Least common denominator of 5 and 4 is going to be a 20. So we use the 20. See what we've got left and clean it up. So 20 divided by 4, well 20 divided by 4 is 5, so that leaves you with a 5x there. 20 divided by 4 is 5, times 2 makes it 10. 20 divided by 5 is 4. 4 times 3y makes it 12y. 20 divided by 5 is 4. 4 times 2 makes it an 8. And that equals a minus 3x. Clean it up. So we have 5x. And then we've got, and I'll move things around a little bit, clean it up. We've got a 10 and an 8. So then we have a 12y. And we've got a plus 18 equals that negative 3. And I'm going to move that 18 over. And now we have 5x plus 12y equals minus 21. Now all the fractions are gone, so now we just eliminate and we're done. So the hard part's over. We did the hard part. We cleared out all of our fractions. We're very careful not to make mistakes. It is easy to do. It's easy to copy something down wrong. But now let's finish it. So now let's take our two equations. So we've got x plus 2y equals a negative 11. And we have 5x plus 12y equals a minus 21. So that's our two equations. I would say eliminate for x. And if I say eliminate for x, what would you multiply that top equation by? Anybody got any ideas? We want to eliminate the x here. Okay, this one's a 5x. I want to make this a negative 5x, right? So what would I multiply it by? Negative 5, right? That's going to make that then cancel out. So let's do that. Distributing through. That leaves you now with a minus 5x minus 10y. Negative and negative makes it a positive 55. Down below we have a 5x, positive 12y. And that equals your negative 21. Adding down, we now end up with, the x's cancel, we end up with 2y equals, we've got 55 minus 21, that's a 34. Divide by your 2, and that gives you y equals 17. How do we get the other solution? Well, we get the other solution by taking it and doing what? Plugging it back in. Okay, so let's see. Did I make a mistake somewhere? I don't think that I did. Let's double check and make sure. I think everything looks right here. It said it should be a 17. I got a 34. Let's make sure that I didn't make a mistake. Well, I don't think that I did, but we'll take this and we'll plug it back in. Okay, so we'll just take this variable here and we'll plug it back in. Now, where do we want to plug it back into? Whatever's easiest. So, it doesn't matter. I'm going to plug it in here. Plug it in wherever you want. So, I'm just going to plug it back in here. So, we're going to plug that in. So, we got x plus 2 times your 17. That equals your negative 11. So, now we've got x plus, we've got 17 times 2. That's your 34. We're going to move that 34 over. And we now have x equals, those go together, 34 and 11, they're both negative, negative 45. So my answer would then be negative 45, comma 17. I'm going to work out one of your homework questions. And I'm also going to pass out the sign-in sheet. So here's the sign-in sheet. So make sure you sign the sign-in sheet. I'm going to do one of the homework questions for you real quick. There's two of them like this. I'm going to do one of them. So I'm going to do question number 8. You can do 7. And this is going to be out of your homework. So I'm going to do question 8. You can do 7. hopefully we can get through this one. Shouldn't take that long, I wouldn't think. Or at least I'll get you started. I may not be able to get through all of this, but I'll at least get you started. I'll at least clear the fractions for you. Well, if I want to clear out these fractions, first thing I notice is I've got x's and y's down below. And I've got the number 8. So I'm going to take this first equation, and I'm going to multiply every part. Well, let's see if I do that. Yeah, let's do it an easy way. So let's take our two equations, and let's look here. Okay, I think it'd be easier if I don't clear the fractions. If I look here, this is a 3, and that's a 6. So I can eliminate this piece here by multiplying it by what? Okay, this is a 3, and this is a 6. If I take this piece here and I multiply it by a -2, that's going to make that a -6, and that'll cancel with that. And we're only using the top. So let me get that 8 on there so it doesn't look like it's part of it. So we're going to take and multiply everything by a -2 in that first equation. And let's rewrite what we've got. Okay, so that's a -6x. -2 times that 4. That's a minus 8y. And -2 times that 35. So we've got -2 times that 35. That should be a 70, isn't it? It's going to be a, watch your signs here, -70 over 8. Now, down below, I already have a 6 over x. So that's nice. They're going to cancel out. And then I have a -3y here. And then that's a -9 over 4 here. This is nice because, look, these are the opposites, aren't they? So they're going to be gone. How do I handle this? How do I clean this up? Well, these can go together because they have the same denominator. So this is the easy part. -8 minus 3 makes it -11 over y. However, this part right here, we've got to get common denominators. And what do we know about -70 over 8? -70 over 8, we can reduce that a little bit. That way we'll get the 4. Because -70 over 8, well, that reduces down to a -35 over 4. Now these have the same denominators. They can go together. So we've got 35 and a 9. That makes it a -44 over 4. How would we solve it for the y here? Cross multiply. And we'll do that real quick here. And we end up now with, when we cross multiply, a -44 equals a -44y. Divide by your -44. And y equals then 1. How do you get the other piece? Plug it back in. So I'll do that real quick here. Let's plug that 1 back in for the y. It's going to be really easy. Doesn't matter where you plug it into. I'll just plug it in here. So we'll plug in that 1. So we have 6 over x minus 3 over 1 equals -9 over 4. You can solve it however you like. I'm going to clear out the fractions, and I'm just going to multiply this by a 4x. I think that's just going to be the easiest way to deal with it. So multiply it by a 4x. So the x's cancel. 4 times 6, that's a 24. Okay, nothing cancels there, so 4x times a negative 3, that's a minus 12x. 4x. And that 4, well, those cancel, so it leaves you with a minus 9x. And I know these take a little bit of time. I'm sorry about kind of rushing through it, but we're almost out of time. And I want to make sure we don't go over time. So we're going to add our 12x over here. 12 minus 9, that makes it a positive 3x equals 24. Divide by our 3. So x should equal now 24 divided by that 3 is 8, right? Not 7, sorry about that. Should be an 8 there. And what's my answer as an ordered pair? Well, the answer is 8, comma 1. Now, that was question 8. Question 7 you can do, but it's the only one that's complicated like that. I did 8, you can do 7. And what's your homework? Well, your homework is going to be 5.1 and that 5.2. They're the same section put together. You should be able to do all of them. So just that first page, that's 5.1 and 5.2. I will see everyone then.